some advice to younger engineers or our students. A couple of things I never want to hear.
Sure.
I never want to hear that's not my job. If you're part of a team, then in some ways it is your job. An example is we were working on a project that had an outdoor courtyard area,
Okay.
and architecturally we laid it out. Structurally, we're designing walls and stuff like that. Electrically, we are putting in lights. We say to the plumbing engineer, we need some drainage out here. It's like, he says, I ain't doing that. Not my job. What do you mean? It's outside the building. That's a site civil engineer's job. We don't have a site civil engineer for this. Well, it ain't my job. I'm not doing it. It's like, you don't understand. The project manager is telling you to do this. Not my job. So the project manager, happened to be an architect, and we laid out really just some surface drains, pitching the patio slab to a couple of minor little trench drains and stuff like that.
Yep.
It's not rocket science. Guess what? That plumbing engineer loses his job later. Not necessarily because we had the economy was bad for everybody, and when it was time for people to be let go, he was let go. And I'm thinking to myself, it's because you're saying it's not my job. Well, it is your job, and if we're part of a team, then you can't just say I'm isolated from everybody else, because your work affects everyone else's, and everyone else's affects your work. So I never want to hear it's not my job. I've heard that from many people in my current employ.
Yep.
And I can honestly say that every one of them is no longer with the firm.
Sure.
The other thing I don't ever want to hear from anybody is, I don't know, that's what the computer says. Well,
I grimaced.
yeah. Off camera, you're grimacing, right?
Yeah,
because you've run the same thing. Tell me what's going on here. I'm talking to a geotechnical engineer about a pile cap analysis.
Okay.
I don't know. That's what the computer told me. Well, how did you model the top of the pile? Did you model it fixed or pinned? I don't know. That's what the computer told me. It's like, well, what parameters did you use to model the soil? I don't know. That's what the computer told me. Like, I walked away and said, forget this. Because I can run the program. Anybody can run the program. You hit start and it runs, right? But he didn't know whether the computer program input variables were proper or not. We can always find somebody to run the program. But it's the professional engineer, quote unquote, professional, not necessarily licensed, but the professional that will say, these parameters are correct, these ones are not correct. Because any spreadsheet will tell you 1 + 1 is 2. But maybe the question is not, is 1 + 1 = 2? Maybe the question should be, what is 1 + 7? But the spreadsheet doesn't know if that's the right question or not. It just tells you numerically what the answer is.
One time, this was in a capstone environment, but there was, you'll see how it connects. The geotech team, one, took 14 weeks to try to answer the question, are we going to use deep or shallow foundations?
Yeah.
And I don't know if they ever really get there. I just said, it's a made-up project, pick one. But you have to make a decision.
Yeah.
Right? But in a similar vein, there was a basement, a 20-foot wall, 20-foot tall basement wall, reinforced concrete. The reveal after X number of hours of calculation and thorough analysis was, we want to use a 7 1/4 inch thick concrete wall, reinforced with number 4 is a 12.
Yes, right.
Of course. But look at the spreadsheet.
Uh-huh.
I could care less about the spreadsheet.
Exactly.
How could you tell another human that you'd want to do a 7 1/4 inch wall? The
But that's
calculations
what the
don't.
computer says.
That's what the computer said.
Yeah, yeah, yeah.
It's a student, not a professional, but he's sitting in an engineer's seat somewhere,
Yeah. Probably got a job, graduated, and working
crushing
right
it.
now.
Yeah.
Yeah, yeah. So, and then you, advice for people: one, don't ever say it's not my job, because it is. Two, don't ever say that I don't know. That's what the computer said. And three is don't be afraid to try. Right? Nobody is going to purposely let you fail, but try. And if it doesn't work, then so be it. But try. We're also paralyzed with fear that we can't do this, we can't do that. It's like if to use a dating analogy, when you see a girl out there, you get a lot of no's before you get the yes. And guess what? The yes ends up being your wife. And 25 years later, you're just as happy or happier than 25 years ago. So, but what if she says no? Well, guess what? It's not a question of if, right? It's not a question of will you do something wrong. It's a question of when.
It's like you take what's another analogy too? Major League Baseball players. If a Major League Baseball player screws up at the plate 7 out of 10 times, he's a multimillionaire.
Yes.
So it's
Yeah.
maybe not exactly, but that's an analogy of trying is important, and
Right.
um,
Because
I
you're never going to grow. You're never going to grow. And if you are stuck in a dead end job that you hate, your life is going to be miserable.
right.
So try something new. That, and who knows nobody knows what they want to do once they graduate college. Right? Okay, you graduate, you got a degree in civil engineering. Well, do you want to work on high-end residential? Do you want to work in high rises in Singapore? Do you want to work on bridges in a third world country to make life better? I don't know. I just want a job, right? Okay, well, try each of them and see which one you like. But
Thing I'm a sucker for stories, especially old school and 1880s engineers, 1920s. Because there's no calculation programs,
right,
but there was a chutzpah or a drive to say, well, I'm just going to give it a whirl, and I'll iterate my way to these things.
mm-hmm.
They, these structures, they're pencil and paper at best, but they created great things. Analysis programs, and we've lost some of it in this drive to quantitate.
Yes, we have. And a similar thing was said when we went from hand drafting to AutoCAD.
Okay.
It's like when we went to AutoCAD, the old school people said, "Oh, you're gonna lose your feel for the drawings. You're not gonna know how to lay out drawings." Right? And there's a method to laying out drawings. You just don't draw detail, and throw them anywhere on the paper. There's a way to organize your drawings so they look reasonable.
Right.
And a lot of that was lost because when you're drawing, particularly with ink on Mylar, you can't erase. So you had to be very, very deliberate in what you were doing. And now all of a sudden with AutoCAD, it's like, I can move the detail up here. I can just take it off the sheet. I can delete it. I can start over. I can do anything. And that understanding of what you're drawing goes away because we went from we went to a truly a technician level. It's like the AutoCAD people, just give me something to draw and leave me alone. And there was a loss of that. And then when we went from AutoCAD to Revit, there was another loss in the sense that you're building things in 3 dimensions, but don't know that asking for a dimension from here to here. And I remember him saying it's like 17 foot 3 and 5/16.
There you go.
Let me know if you need to be more accurate. It's like, no, 17, it's not going to get built that way.